So this is the demonstration video for our semester project for information security. And before we move into the details of the code and how the project works, I think it's important that we start with the encryption algorithm that we will be using in our project, which is the triple DES algorithm. And even before talking about triple DES, we first need to talk about what is DES, which is the basic encryption algorithm that is employed in triple DES. So if you open up picture here, so this is basically the demonstration of how the DES algorithm works. So basically we have a sort of 64-bit text block, which is the, if we can say, in plain text that we want to basically encrypt. Of course, doesn't have to be necessarily plain text, but for our example case, we are using plain text. Of course, in our project, we are basically using the triple DES to encrypt images, but the general idea is the same for all. So, and then of course we have also a 56-bit key that is used for encryption and subsequently for decryption. And then we have a certain number of steps that are involved in the DES algorithm. The first of which, of course, is marked here as the initial permutation, which is where the order of the bits of our data are changed and moved around, to gain a different combination as a result. Next, we have the you can say the main sub-process of the encryption algorithm, and that involves basically a few steps that are repeated for 16 rounds. And so basically the same 3 or 4 steps are repeated for each of the 16 rounds, and for that we basically need for each round a unique 48-bit key. So basically for that, what we do is we use the original 56-bit key that we have for our algorithm, and we pass it into a round key generator that then gives us different combinations of 48-bit keys. So basically, unique 48-bit keys using the 56-bit key for each of our 16 rounds. So what happens in each round is that basically we have the 64-bit data, and that is divided into two equal halves. So then we have basically two halves of 32 bits data each, which is where we will have the least significant 32 bits and the most significant 32 bits. So we use the least significant 32 bits and we expand them to 48 bits, and then we exclusive OR them with the 48-bit key that we have generated for that specific round. The result that is gained from plugging both of these values, the 48-bit expanded least significant bits as well as the 48-bit key that we have generated, we by plugging them into the input of exclusive OR, we gain a result. That result is used to look up values for substitution. So so that is the second step, is the substitutions. First step is exclusive ORing, the expanded least significant 32 bits with the 48-bit key. Next step is substitution. After that, we have a result that is then exclusive ORed with the most significant bits of our original data, and the result that is gained from that exclusive OR process is basically stored as the least significant bits of our resulting data, or our result, you can say, from the specific round. And then so basically we have the least significant 32 bits of our result. The most significant 32 bits of our result are basically the least significant bits of our original data, that is input. So basically what we have is we have 64 bits of input that is divided into 232 bits. The least significant bits of input are expanded to 48 bits and exclusive ORed with the 48-bit key that is generated. Next, it is used to look up values from, you can say, the substitution table to apply the process of substitution, and then the result is exclusive OR with the most significant bits of our input, and so we gain the least significant bits of our output, and then the most significant 32 bits of our output are gained from the directly plugging in the least significant bits of our input value. So this process is then repeated 16 times for all of our 16 rounds, and at the end the result we get is then passed into what is called as the final permutation, which is basically the inverse permutation. So the process that we applied to change the order of bits originally here is then basically reversed and applied for the final permutation, and as a result of that we get the cipher, the encrypted data at the end of this whole process. Now for the decryption side, the same logic is applied, but of course the order is reversed. So first we have this final permutation, and then of course the order of the rounds is reversed, and at the end we have what was in the original, the initial permutation will now be the final permutation, the final will now be initial. Similarly, the rounds will also be reversed. For decryption, the same key will be used again, to produce 48-bit keys, but of course their order will also be replaced, so the key 1 will now be the key 16th, and key 16th will now be key 1. So this is basically the general idea of how the DES works, and the triple DES is basically an evolution of the original DES algorithm, which is basically where we sort of apply that DES method 3 times for encryption and then 3 times for decryption, hence the name, triple DES. And of course it's stronger than the original DES algorithm, as well as another evolution which was the double DES. It's also stronger than both of them, as well as that it also, another advantage of it is that it allows for varying sizes of keys that the original DES algorithm does not allow. So what happens here is that, of course, the DES method, we have the same number of steps, but of course for encryption and decryption the orders are reversed. So basically, when we're talking about triple DES algorithm, we first have the encryption part, where what we do is basically we start with applying the DES encryption method using key 1. So the keys here will be basically 3 in number. So we will have 3 keys that will be used for encryption, and then those same keys but in different order will be used for decryption. So of course the key sizes, as we discussed, can be of different sizes, but for our project we are using 16-bit keys. So let's say talking about 16-bit keys here. So basically we have one 16-bit key that we call as key 1, that is used in the DES encryption method that we just discussed. So then what happens is that we will again apply the DES method, but this time the decryption method using key 2, and then again DES encryption using key 3. So basically what we do is we apply encryption, then decryption, and then encryption. So basically 3 steps in our triple DES algorithm. And of course within the encryption and decryption, the disk process that we just discussed regarding DES is applied, of course with varying order. So this is, and of course at the end of it we get our encrypted data. And similarly, when we talk about the decryption side, we again have 3 keys, but the same 3 keys, but the orders are reversed. And similarly, the order of encryption, whether encryption process is applied or decryption process is applied, is also reversed. So if we talk about it, here for encryption we first had DES encryption, but now we have DES decryption. And also the key is of course key 1, but order is reversed to key 3. So similarly, encryption, now decryption, then decryption, now encryption, then encryption, now decryption. Again we had key 1, now we have key 3 first, then we have key 2. Of course its order will remain the same, and then we have key 3, but first we had key 3, now we had key 1. So the order of the keys is reversed, and the order of whether encryption is applied or decryption is applied is also reversed. The first, so first of all we get the decryption, we get the encrypted data, and then we get the decrypted data. So this is all there is regarding how the encryption algorithm works. Next we'll talk about how we are basically using this algorithm in our project. So the basic idea of our project, as we discussed in our proposal as well, is that we will have a website with sort of 2 sides to it. So we have an encryptor or encryption side, and then we have a decryptor or a decryption side. So what basically happens is that a user creates an account on a website and logs in using the credentials. He or she is then able to upload an image onto our server, and that uploaded image is stored on our server after being encrypted by the triple DES algorithm. So basically we have an encrypted image that is stored on our server, so no one other than the person that has access to the 3 keys that are used for encryption will be able to decrypt that. So that is the encryption side. A user uploads an image, we apply the triple DES encryption process, keys are generated, and we have an encrypted image that is then stored on our server. In our case we are using a local server, which we will discuss further in detail. So then we have the other side where another user who is also who also has an account on our website, logs in, and if he or she wishes to see our image, because of course we will have multiple numerous images that will be uploaded by different users onto website, but in order to see that specific image, they will need the three keys that are generated or that are basically used for the encryption part. So of course they will be passed on by the uploader through certain, whatever mode that they want to use, and then the second user will be able to type in, and input those keys in their specific order, and then they will be able to basically, first of all, the decryption process is basically being done at the back end. They will then be able to see the image, of course, be able to save it on their desktop or whatever, device that they are using. So next we'll move on to discussing, the implementation and the code of what we have done. So basically we have two sides to our code. We have the actual implementation of the algorithm, and then we also have, the website part, or the HTML and the JavaScript and all of that. So what we'll basically do is we'll discuss both of them simultaneously, whenever whatever step they are needed. Or basically, I think it's better if we discuss the encryption algorithm firstly, what's happening, and then of course wherever the JavaScript or the HTML, or the front end is basically, or the local server is used, we'll discuss that as well. So first we'll talk about little bit about the front end and the implementation of our website. And first of all, these are the JavaScript files that we have. So these are the HTML files of our website. So this is basically if you look at, start here with the sign up page. So this is basically the HTML file for sign up. It has certain elements to it. I think because it's more related, the project is related to information security. So I will not discuss HTML and that in too detail. Just the important points that are needed for implementation. The rest, if required, can be implemented if needed, or sorry, explained if needed. But to not let this video go too much in size, I will not go in too much detail about HTML and each and every point. So this is basically the sign up page, and we have certain functions that we implementing in that as well, for the take name and the take pass and hello. We'll talk about that as well. So basically this is the sign in page. So basically what we have here is that, they once user, basically the user being able to log in, so, they type in their username and the password, they like, and just basically what happens is after they click that, a request is sent to our local server. It checks where the database is there. If we go here, so basically this JavaScript file is basically houses our local server and all of the handling that we're doing for that. So basically what happened is that, basically if we move down here, so if you're talking about the sign up page, where the user types in, their username and the password, the details to create an account. After clicking, sign up, the basically a request will be sent to our local server. So this basically handles that, so basically taking the username and password that has been sent in that request, and so before we discuss that, I should add that we're using MongoDB as the database, to house our all our accounts, and so we basically got the idea to use MongoDB after studying about SQL injection, and as we know that MongoDB is a NoSQL database, and so it helps us avoid SQL injection attacks, as it does not use SQL. So that was basically the thinking or the idea behind using a MongoDB as our database. So before going into detail and talking more about the website or the subsequent code for that, we'll first discuss the actual code for the encryption algorithm. And we basically use Python for the implementation of the triple DES algorithm, and we have basically have two Python files for that, one for the encryption and then one for decryption. And we're basically using a Python module known that is named as PyDes for the implementation of the triple DES algorithm. So we're basically just importing that over here, and then we're also importing random and string. That's basically we were using it for the creation of the 16-bit keys that we are using within the Python files, but we've moved that now into our to the local server side. So it's because it's better, firstly for better implementation, but we'll discuss that when we go towards that as well. So basically, these three keys are being generated are not actually being used anymore. I just forgot to remove this part. So anyway, so basically this is the encryption side of the, as I said, and we have one main function which is named as encrypt, and we're basically calling that here. This sys.arg is basically, you can say it's a list in Python that contains the command line arguments that have been passed to the script, where the first argument is the script itself. And so basically, of course, as I'll discuss a little later, that basically the local server that is triggering this Python file, these are the arguments that are being sent over from that side. So basically, they are stored in the sys.arg. And of course, basically, sys.arg1 is basically the file name that, or the file path where we want to encrypt the file. So I'm leaving that for a little later, but now we'll just discuss the actual encryption and decryption. Then we'll discuss about that as well. So first of all, what we're having here is that we know that for triple DES we have encryption, decryption, and then encryption. And so basically, first of all, talking about the encryption side, what basically we're doing is we're basically just calling the open function, which of course basically opens the file and just returns the file object, and we're basically giving it the argument name which is given to us from the local server. So this is basically, for now, this will basically be the just the file path where the image that we want to encrypt is basically stored at the moment. And of course, this is the first mode, which is the RB mode, which is basically opens the file in for reading, in the binary format. Next, what we're basically doing is, we've basically initialized basically gotten the file object, and we're using, of course, it has a couple of functions, read and write. So we're using the read function and then storing that data, in the binary form in just a simple variable which is named as pick data, and then we just close that file. Next, basically what we're doing is that we have a few classes, basically two classes in relation to the PyDes module, which is the DES and the triple DES. So basically what we're doing here is we're initializing the triple DES class, and it has certain arguments that are given to it. The first of argument is basically the key that will be used for, in this case, encryption and subsequently for decryption. So the first key basically that is here, and again, as I discussed, these arguments are mm, basically coming from the local server that is triggering this file. I'll discuss that, as I said before, later. So this is, for now, this is basically the key, 16-bit key. Then we have this CVC, is basically, if we triple DES, we have for in the PyDes implementation, we have two basically modes that can be applied. So we were basically using the cipher block chaining mode, and of course, as we know that what happens here, that in the cipher block chaining implementation for triple DES, or DES to be precise, that we basically break the message into blocks, and then each message block is encrypted using the triple DES and the 16-bit key that we have. And basically the added, you can say, part in this is that before the message block is actually inputted into the encryption basically, or into the encryption algorithm, it is basically passed into an exclusive OR gate which has two inputs. One is, of course, the message block that is coming from encryption, and the second is the previously encrypted block. So of course our message block will be, say, divided into 5 blocks. So for one block, for example, the third block, where basically for encryption we'll first exclusive or the message block that is coming in for encryption and the previously encrypted block, and the result of that exclusive OR gate will then be passed into the encryption algorithm. But of course, one key issue here is that for the first message block, there will not be a previously encrypted block. So for that, we have what is called the initialization vector. That is basically the third input or the third argument into our, for the initialization of the triple DES class. Then it's basically we have padding we set to none, and pad mode pad is set is this. This is basically, by default that we were able to understand from the online resources. So next, of course, the class has been initialized, and then it has a couple of functions of its own, which is encrypt and decrypt. So for, of course, this is the encryption part. So we're basically using the encrypt function, and of course the implementation, as we just discussed, what basically happens in the encryption part in quite detail at the start. So basically the DES encryption method is applied here, and it's we basically store that in the big data. The encrypted data that we have is stored in the variable, and then we open up the same file because we want, that specific file to be encrypted. So we again open that file and we just write that encrypted data back into that file. So that completes the encryption part. So basically, we've initialized the triple DES class, then we've of course set certain arguments that needed to be set, and then we've used one of we basically triggered one of its functions, which is the encrypt function, and then we've gotten the encrypted data that is then written back to that same file that we read from in the first place. That really is the encryption part. Then we have decryption. Now, of course, for the other processes or the other parts, the general application will be the same, but for decryption there will be a couple of changes. The first will of course be that, the initial stages are the same. We again open that same, file path. This time again with, right. Of course, one thing I forgot to mention here is when we're opening for writing back, we will of course open with the mode WB, which of course opens that file, again by format for writing as opposed to reading, because now we're basically writing back to our file. So again, for then moving on to the decryption, again we'll first, open that file, with the RB mode, and we'll of course again copy that data into we'll basically store the data in a, basically, you can say, a variable, and using the read function we'll again initialize the triple DES class from our PyDes module. But of course now the key will be different, because of course we will be using three different keys for each step, for each encryption and then decryption and encryption. So the key will be different. The other arguments are the same. We're again using cipher blocking chain with chaining, and we're again using initializing vector, and pad is none, and of course the pad mode as well. But of course now we will, of course, as I said, the triple DES algorithm has the triple DES class basically of the PyDes module has two functions. We use encrypt for the encryption part. Now we will use decrypt. Again, as we discussed at the start of our video, that the how it actually is implemented, the decryption part. So after we're again storing that in a variable, and we'll of course again open the same file, and then we'll write back that data again. And for encryption, we will again repeat the same process. It will again be pretty similar to the encryption part. The only difference will be the key will be different, the rest will be the same. So with very little minor changes, the general idea will be the same for encryption, decryption, and then encryption similarly for the decryption process as a whole as well. So that is basically the general idea of what we're trying to implement here. So next we move on to the decryption side, and so the general idea, as I said, the general implementation will be the same. Of course, this time we missing a few things missing here are the keys, which I said, of course, that anyway we do not need to generate here, but anyway we are using them on the local server side, or creating them on the local server side. So that is missing from here. So then the rest of the part is the same. We again open that same file, and we again read from that file. Of course, one thing to mention here is that what we're basically doing is, because we will be housing multiple different images on our server, so to differentiate them, what we're basically doing is, as I'll show you a little later on the the local server side, we're basically storing each of the images that are being uploaded with their name being set as the third key that is being used in the encryption algorithm. So basically what we're doing is that we're basically generating new keys for each time we basically encrypt an image. So the of course those three keys will be uniquely generated, and we're using the third key for each generation as the name of the image that we are storing on our local server. So what that basically will do is that will help us in identification of the image, when it is time for to decrypt, because we're just using the three keys as input from the user that will then be used to decrypt the image and show it to the secondary user. So we're basically, to differentiate between them, we're basically naming them as the third key of each encryption. So basically, on this side, what we basically have is we'll have the same file path, but of course the specific file name will be that of key 3, of the third key of the encryption, as I just discussed. The rest of the process is again the same. We'll again, open it in the read mode first, and then of course we'll store that data in a variable. We'll close the file. We'll again initialize the DES class. Again, the arguments will again be the same, other than the first argument, of course, because the key is different. Of course, it's the three keys that are being used for encryption, but in different order. So the rest of the arguments will remain the same, and of course we'll be using the two functions, that encrypt and decrypt functions, that are part of the DES class of the PyDes module. And of course, again, after decryption, the data will again be written back into the file, and similarly for encryption. So I'm not going into much detail of each step, because it's just a carbon copy of what we discussed in the encryption side. The only difference is that the order of the encryption and decryption steps are different, based on the triple DES algorithm, and the only other difference being that the key orders is different here. Other than that, the entire implementation is the same. So I'm not going into much detail regarding that, but of course, the initialization of the class triple DES class, the implementation of either one of its functions in the encrypt function or the decrypt function is the same. And of course, similarly, we're opening that file and reading from it, and then we're writing the encrypted or decrypted data back into that file. And at the end, of course, we will have our original data that is stored on our local server. It will be decrypted, and then it will be shown to our user. So that is the entire logic or the code behind our implementation of the triple DES algorithm. Next, we will move on to our website part. And so again, because the video is anyway getting really large, and it is important to keep the focus on things that are related to the information security project and the course itself. So I'll not go into too much detail regarding the website. Like, I'll not talk about each and every HTML file, and how each of the paragraphs, or you could say the form items and all of that are implemented, because this is not a web development course. But I will talk about the implementations that are very important, or they are critical to the implementation, and the most important of which is, of course, our local server that we've created. And we'll just talk about a few of the functions that are implemented here. So basically what happen is, whether a user is basically signing up for an account on a website, whether he is signing in, whether he or she is uploading an image, whether he or she wants to decrypt and view that image, each of that will basically trigger, after the user types in, for example, the username and password, and then click sign in, or something similar happens. Each of those processes will basically trigger a request that will be sent from our website to our local server, and subsequently, certain functions will be triggered that will handle those requests, and do the required steps that need to happen. So basically, if we talk about just quickly a few of the functions, so this is basically a function that basically handles the sign up request from the website. So basically, the user types in the information that is required, the username and the password that is required for an account, and those basically are sent to our local server. It basically, as we discussed, we're using MongoDB. So basically what it does is it basically creates another entry in our database with the new username and the new password. Similarly, this function here is basically handles the sign-in request. So basically, the user types in their username and their password, and after clicking sign in, a request is sent to basically check to the local server to basically check, that whether the certain username and password exist on our database. So basically, this is just a function that basically just, you know, triggers a query to the MongoDB database to check, whether the username or password that is sent as part of the request, do they exist in our database? If they do, then basically what happens is that a session is created. So basically, we're also using sessions in our website, so basically to help differentiate, different users, those that are uploading, those that are trying to decrypt. And of course, all the implementation took a lot of time and a lot of researching as well. But again, as I said, I'm not going into too much detail because then that will take a lot of time up in regarding things that not are not necessarily directly related to information security. But I encourage you, sir, to ask us regarding anything you feel that we have not included in this demonstration, that you feel, from the part of the local server or the implementation from the web application side, that you feel, that should be answered but has not been included in the website. Because as I said, I'm trying to keep this video from going too much in length, so I'm basically trying to reduce as much from the website part as I can without compromising on basically the quality of the project and the quality of the demonstration video. So please, if you feel like anything is missing, do message us regarding that so we can clear that issue. So next we'll talk about the practical demonstration. So there are a couple of more things that I need to discuss, but I'll move towards practical demonstration, and when that specific time comes, I'll also discuss that as well. So if you move on to the actual demonstration of our website, so if you open this up tab, so as I said, we're basically hosting our website on local server, and so this is for the sign in or the sign up page, you can say, for our website is here basically. And so you can basically type in the username and the password to create an account, and we have already created an account to save that time. So I'll just basically quickly log in, to click sign in, and of course as I said, the at the back end, that request has been sent, and this check from the database that this user exists, and then they've logged in that specific user. So next, of course, we have the two main parts of our website, where you can upload an image, and then we can, of course, we can download an image, and of course, all the encryption part that is also involved with it. So basically, if we'll talk about first the encryption part. So basically, the user clicks on this choose files button, and then we'll basically be able to pick and any image that he wants. So say we want this image to be uploaded, so we click that, and then we click the upload button, and then after that, of course, all the stuff at the backend is triggered. So basically, a request is first sent to our local server, that then triggers the Python files that we've linked with that, and of course the encryption part that we just discussed here, which is this part. Of course, all of this is basically triggered. So it basically happens in two phases. So first of all, after the upload is basically clicked, the server basically first stores that image locally. Next, basically what it does is it then triggers the encryption process that then takes that locally stored image and encrypts that image and stores it back in that very same place. So after that encryption process is completed, we'll basically, of course, we'll need the three keys that are then generated, for the encryption process, that then will be required for the decryption process as well. So basically, once that encryption process is completed, the user is given, these three keys that they need to store. It's also, said that, you should save them for decryption purposes. So if we just stop here and talk about what happened at the back end a little bit. So basically, once that upload button was clicked, a request was sent to the local server. We're basically using a couple of modules of Node.js Multer mainly for the uploading part, and then simultaneously the what you can say, the downloading part, or not necessarily the downloading part, but the showing of the image. We're basically using Multer, which is a Node.js module. And so basically this is the request that is sent to the local server once the upload button is clicked. This is an important part here. Basically what we're doing is we're creating three unique 16-bit keys that will be used for the encryption process. And as I discussed while discussing the algorithm, that we're basically creating these three keys on the local server side, and then they are sent along with the trigger for the Python files. So basically, what we're doing is that we just using for loops, and then just using a couple of functions, random and floor, to basically keep the values within the certain amount. We basically what we're doing is that we created these characters, with the capital letters from A to Z, and then 0 to 9 digits, and then we basically randomly sort of concatenating them together to create the 316-bit keys. Next, what happens is basically we're using another Node.js module which is called a spawn, and what that basically does is that it basically triggers the Python script, and these are the basically, if we talk about the sys.arg. If we go here, this basically sys.arg that we said was a list that contains the command line arguments. So basically, these are those arguments. So for as I said, the first argument is always the actual script. Next, we have the basically the file path where we want to store the image, and subsequently, from where we'll pick up the image. And what we're basically adding is the key three. As I said, we're storing each of the images that is being uploaded with the third key as the name. So basically, this is just concatenating the actual images folder path, and along with that the key and the extension, which is keeping as .jpg. Along with that, we're sending three keys that we've just generated here as well. So if we talk about, so we are basically doing that because if we go here, and basically because we're using a local server, so we're basically storing all of the Python files and the JavaScript files and the HTML files in this specific directory. And in that we have this images folder, which is where basically all the images that are uploaded and then encrypted are basically stored. And so as you can see here, this is the image that we have just that the user has just uploaded, and as we can see that it has been encrypted, and we are unable to see what it actually is. So this is the reason why we're basically concatenating this images slash file path along with the the image name and also the extension. So what happens after this process is completed is that we of course need to send the keys that have been generated to the user, because they will then be used for the decryption side. So basically just send back a message to the user where we are concatenating the three keys that have been generated into the string that is sent as a message back to the user. That we of course we just saw here that will be shown in this way to the user. So what I'll basically do is I'll basically copy all of that and store it somewhere. So I'll just quickly open this, and I'll just paste this here. Right. So now what we'll do is basically we'll close this tab, and because we want to create a new session. So now we come back here, and of course now we move on to the second side. So say a user now wants to log in and view that image. So we log in with a different account. So after logging in now, to view the image, the user needs to input the three keys for that specific image. So we'll just basically do is we'll copy these keys. So as you can see, key 3 goes here. Then we have key 2, and then we have key 1. And then of course I'll just click the show picture button. And of course, as before with the encryption side, the similar process will again be triggered, where a request will be sent to the local server, and again the spawn module will be used, but this time to trigger a different file, which will of course be the decryption file that we discussed. So then the image, pardon me, that has been uploaded, that will be basically decrypted through that decryption file, and as a result of that we will basically be able to, or the user that is logged in will basically be able to see the image. So when the process is completed, basically a message will appear saying that the image has been decrypted successfully, and once we click OK, so as you can see the image has then been displayed to the user. So this is basically what happens. If we talk about a little bit what happened at the back end is, as you can see, a similar function to the one that we used earlier. Again, the spawn module will be used, and again we've got the same the script as the first argument. Of course, as you can see, there's a difference in the name because this is now the decryption file, decryption Python file, and of course the, you can say, the image path will be the same. But of course, now because a request has been sent from the website to the local server, and as I discussed before, that we are saving the name of the image as the third key. So basically, as once the show picture is clicked, it's basically a form that then sends all of those three inputted values along with the request, and we're basically using the third value, which is the third key, because that is the name of the image. As I said, there will be multiple or different kinds of images uploaded. So to differentiate, we're basically using the key as the name, the third key as the name. So basically, it's just combining that to then pick up that specific image and basically trigger the decryption file, along with, of course, the three keys that, of course, will also be inputted, that have been inputted by the user. And again, the same logic is applied again. As you can see, this now this 3 des rev, which is the decryption file, will be run, and of course all of these processes that we have discussed, all these steps will be implemented, and we will get our decrypted side file that will then be the decrypted image that will then be shown to the user. For the showing of the picture, we actually have a separate function, which is this function, that of course is happening at the front end. So it is linked to the main page of our website, and what it basically does, it is only takes, as with the what you can say, the local server. So basically, this is the function that is being triggered when the person clicks the show picture button. And of course, what it does is it basically sends a request to the local server to decrypt that specific image. And after that function has been completed, it only simply does is that it takes that image that is stored at that specific location, and it just shows that image onto the page. So of course, if the image wasn't encrypted correctly, the user will not be able to see the image. It would just be a blank page, not showing any image, because actually the image is being shown, but as it's not encrypted, so no actual visual is being shown. But of course, in this case, the file was encrypted, or sorry, the file was decrypted correctly and successfully, so we can see that. So thank you very much. I hope that this video, it's a detailed video, and I hope that I followed all of the steps as required, and that this is now clear to understand all of the steps, from what is triple DES to the idea behind our project to the actual code for the implementation, as well as for certain parts of the website, and then the actual practical application. So thank you, and I hope that this video is up to the scratch.